Okay, welcome back. Problem number 14, how does this calculate the average velocity? We're given this function, s of t is equal to sine of pi t. So let me write that out. Let me use red. So s of t is equal to sine of pi times t. Okay, and that represents the position of an object moving along a line on the end of a spring. Okay, so basically what I want you to do is to sketch the graph of s together with a secant line passing through the points 0, 0, okay, the function value here is 0, and then at 0.5. 0.5 is right here, and it's at this maximum, okay? And it says determine the slope of the secant line. This means average rate of change, okay? And I'm going to go ahead and connect those 2 points with a line here, okay? And I'm going to calculate that slope, okay? And that slope, folks, ends up being that this is this is 1, okay, and this is 0.5, okay? So if I draw a triangle, I know this length is 1, I know this length is 0.5. So my slope, okay, which is s of 0.5 minus s of 0, all over 0.5 minus 0, ends up giving me 1 over 0.5, which ends up giving me 2, okay? So, guys, I'm just finding the slope between 2 points, okay? Nothing too terrible, nothing too crazy, okay? Let's take a look at number 16. Now, 16, I went ahead and graphed this for you, this function. And so it says you have a position function given by this quadratic. It says complete the following table and with the appropriate average velocities, and then make a conjecture about the value of the instantaneous velocity at t equals 2. So let's go ahead and let me take a little graph here. Let me move, this is 0.2. All right, oops. All right, let me come up here, let me draw a line from 0.2. All right, let me do a line at 3. Ooh, 3 gives us our maximum. Okay, so let's just take a look here. If I calculate the slope, and let me use red. Let me calculate the slope between these 2 points, okay? And if I calculate that slope, I'm not getting a tangent line. I'm not getting the instantaneous. I'm still getting a an average rate of change between those 2 points. But what I'm going to do is I'm going to start putting in values and closer to 2. Okay, I'm going to move this point closer and closer to 2 so that eventually the slope of the secant line gets really, really, really close to the slope of my tangent line. Okay, so what I want to do is I'm going to do this. All right, I'm going to use my calculator. I need to find s of 2 first of all. Okay, let's do that. Let's go to our calculator. And I'm going to go to y equals. I'm going to erase this function. I'm going to turn on this function, and I'm going to make sure that I'm asking my calculator to give me values. So if I plug in, say, 2 here, all right, then I get a value of 60.4. Okay, so we're going to have to go in between our calculator. We're going to use our calculator here. So I get a value of 60.4, okay? And then I want to find all these different values, okay? So bear with me here. I'm going to find s of 3 real quick. And I'll show you what I'm doing here. I'm kind of trying to get all this done. Okay, that gives me 65.9. So this is 65.9, okay? And then let me find s of 2.5. Let me plug that in and see what we get. So we get, let me plug in 2.5, and we get 64.375. All right, 64.375. And then let's find s of 2.1. Okay, and so then I get, let me plug in 2.1 into this function, and I get 61.391, all right, 61.391, 61.391. Let me find s of 2.01, all right, and that should get even smaller, so let's plug in 2.01, okay, and that gives me 60.504, all right, so I get 60.504, Okay, and then let's do one more. Let's do S of 0.001, so 2.001. All right, and I get 60.41. Okay, so I get S of 2.001. That's 60.41. Okay, so as I get closer and closer to here, my y values get really, really close to each other. Okay, so let's actually calculate this one here first. Let me do that in black. All right, and so I'm going to do S of 3 minus S of 2 over 3 minus 2. So I've got my slope for that first one is 65.9 minus 60.4 over 3 minus 1. So I'm going to do that real quick on my calculator. So we get 65.9 minus 60.4, and that gives me 5.5 all over 2. So let's divide that number by 2, and then we get 2.75. Okay, so 2.75. Okay, that's the average rate of change between 2 and 3. Okay, now let's do 2 and 2.5. So that slope, let me do that in red. So that slope gives me, okay, I've got 64.375, so 64.375 minus 60.4 all over 2.5 minus 2, all right? So that's going to give me, oh gosh, this was 1. Sorry, this should be 5.5. My mistake. All right, so I made a mistake, guys. This needs to be the value of 2. And so 3 minus 2 gives me a value of 1. So this is 5.5. Okay, sorry about that. All right, let's do the work down here. So I've got 64.375 minus 60.4. And that gives me 3.975 all over 2.5 minus 2 is 0.5. Okay, so if I divide that by 0.5, then I end up getting 7.95. Okay, so 7.95. All right, let me do this one. So let me do that one in green. And so I've got that slope is 61.391 minus 60.4 all over, and this is 2.1 minus 2. So that's going to give me 0.1 down below, so 61.391 minus 60.4. And that gives me 0.991, so 0.991, and if I divide that by 0.1, I end up getting 9.91, okay, 9.91. All right, so my velocity is getting larger. So as I get closer and closer to a tangent line, it's giving me a better approximation. Okay, now let's do 2 and 2.01. Let me go back to black. So my slope here is 60.504 minus 60.4, and if I divide that by 2.01 minus 2, that's going to divide by 0.01, so 60.504 minus 60.4, and that gives me 0.104. Okay, if I divide that by 0.01, that's going to give me 10.4. Okay, so that's this one. All right, so we're getting about 10.4. Okay, now let's do this one. Let's do the last one. Let's do that in blue. So that slope, 60.41. So 60.41 minus 60.4 all over 2.001 minus 2. So that's going to give me, I just don't want to screw this up. My mental math is terrible, folks. I am not perfect, but I try. Okay, I get 0.01 divided by 2.01 minus 2, that's 0.001. Okay, and so if I take 0.01 divided by 0.001, that's just going to straight up give me 10. Okay, I think I did this right. Okay, looks pretty reasonable. But the question is, what's my instantaneous velocity here? What's the slope of that tangent line? That's the question that we're asking ourselves. Is as we choose values here, the slopes got steeper and steeper and steeper, okay, and we could make a conjecture that the instantaneous velocity, is equal to 10, okay? So that's kind of the idea. We're going to work on this all year long, guys. So if you don't understand it, we're going to keep working on it. and hopefully it'll end up making a little bit more sense to you. Okay, hope you enjoyed this.